Sushant, it may be better in the future to start streaming.
I think it's live, sir. I'm seeing it live. Sushant, please check. It's live. Sir, it's live, sir. It's live.
Good afternoon. Good afternoon, everyone. Sorry about the delay. We were waiting for the YouTube to start streaming, although we were waiting from 5 minutes before 3 o'clock onwards. My name is Kannan Maudgalya. I'm a professor at IIT Bombay. I'm the principal investigator of the project FOSSEE, Free and Open Source Software for Education. It's a project funded at IIT Bombay by the Ministry of Education, Government of India. And the objective of this project proposal of this project is to promote open source software in academia mainly, and also to some extent industry. And one of the things that we focus on is to provide massive training to students across the country. We are working mainly with college students, but we are in a position to train school students also. But what is more important is we train them to such an extent that the students are able to contribute. So that is something unique about this. We have a large number of students contributing to the content developed by the FOSSEE team, content and the program developed by the FOSSEE team. All of them are available free of cost at fossee.in, FOSSEE.in, fossee.in. And as a part of this student training and contribution, we have been doing 3 activities. Hackathon. In hackathon, we completed a hackathon, Scilab Toolbox hackathon. Then we have Synfig Studio based 2D animation hackathon. That is also, in fact, it is ending tomorrow. But the third one, and the most important one for which we have assembled here, is the Mapathon, which we are doing. We are delighted that we could join hands with ISRO. We could also join hands with the AICTE team to do this, to bring to all of you the map, the data that our amazing organization, our space organization, ISRO, has collected and made available for free access to everybody. So that is that amazing data that the participants are going to access. And I'm happy to say that more than 3,000 teams have registered so far. The registration is open till 18th, and so we expect some more teams to join. And then we expect at present about 3,000 teams and 5,000 participants are there, but we expect this number to be a lot higher. And we are really happy that the Honorable Prime Minister has endorsed this Mapathon. I'm sure that we can all get together and do something very useful. So I'm not going to spend too much time. I would like to introduce Mr. Shantanu Bhatwadekar. He is the Director, Earth Observation and DMS Program Office, EDPO, ISRO headquarters. So after he talks for a few minutes, then we will have Professor Pennan Chinnaswamy of IIT Bombay. He leads the GIS effort at IIT Bombay. So he is going to give an overview of this Mapathon itself, and then a brief introduction to QGIS. And then we will have the ISRO team led by Sri Shashikant Sharma and Sri Arul Raj and Sri Nilay Nishant to cover various types of data available. Then we will have Q&A session, questions and answers. I'm sorry, we are not able to accommodate all the participants in this well, actually, we have this Google Meet thing through which we are addressing, but then all the participants are joining through YouTube. We'll be monitoring the YouTube and then answering those questions. But we look forward to your participation, and we are likely to have another inaugural, a formal one, a little later. We are hoping to get our Honorable Minister to address all of you. That may happen sometime in the near future. But today's event is something that we want to get started with, so that all of you who have already registered can roll up your sleeves and get started. So with that brief introduction, I would like to invite Mr. Shantanu Vatwadekar of ISRO. Over to you, sir.
Well, good afternoon, everyone, and greetings from ISRO. Am I audible?
Yes, sir.
Yes, sir.
Yeah. Well, at the outset, I take this opportunity to congratulate all the participants who are joining this hallmark event, Mapathon, using Indian remote sensing datasets and open source solutions. I thank AICTE and in particular IIT Bombay, Professor Kanan, for giving us this opportunity, and also collaborating with ISRO for this mammoth event. Well, as you may know, that Indian Earth observation capability basically comprises of a fleet of satellites providing valuable services for resource monitoring, infrastructure planning, cartography, large-scale mapping, disaster monitoring, meteorology, oceanography, and so on. And these satellites contribute immensely to the big geospatial data sphere by providing rich, voluminous data. And these data sets are utilized to unearth valuable insights, information extraction, and planning and decision making. Over the years, of course, ISRO has operationalized many national level, state level, and region specific level operational applications, basically to address the national imperatives as well as the fundamental priorities of the government. There are many examples like food security in terms of agricultural crop inventory. We provide the advanced, forecast before the harvest, how much production will be there in the country in terms of food grains and also in terms of horticultural crops. Then we contribute to water security through water resource information system and providing the groundwater prospect information for the country. Similarly, forest working plans, inventory and monitoring of glacial lakes, contributing to climate, and there are many more applications, including, of course, the energy sector, which is very vibrant now. Also, ISRO has deployed several geoportals, many of which you may be aware about: the Bhuvan, MOSDAC, Vedas, and the NESDR, specifically dedicated to the northeastern region of India. And these portals are basically delivering the remote sensing products, application, and services, and they reach out to user community. And these portals also provide wealth of data, including the time series satellite information, various thematic layers which ISRO has been generating over the years with the help of user community. ISRO, places very great importance basically to partner with the academia and to work closely with the academia and the student community for developing innovative solutions and ensuring the best of the solutions for the problem. And I think in this regard, this Mapathon, which is a joint effort of IIT Bombay, ISRO and AICTE, it will provide a platform to join hands in leveraging the potential of the Earth observation data from the fleet of Indian satellites, couple them with advanced technology, open source solutions, and provide a lot of tools which requires now the automation, basically to address the timely delivery of many of the services. So you will come to know in the later part of the today's talks that we have identified the 10 problem statements for the user community and particularly the students, wherein we expect that they really utilize the potential of your data and also use their innovative skills and their technological skills to provide the problems, whatever we given, they provide the best solutions for them. Some of them, of course, we have selected the problem statements like you have the land use, land cover change. As you know, the land use is the basic planning unit for any planning, any developmental planning in the country. Basically, you need a land use map. So how you really automate them, how you really find out the change, how it has happened in the land use over the years. Similarly, how you automatically generate the flood maps. Because wherever the disaster strikes, our idea is basically to deliver the information maybe within an hour. So how automatically you derive the flood layer from the satellite imagery. Similarly, how you address the locust problem, which you have seen quite recently. If you have the problem of air quality, particularly the residue burning in the northern area and the pollution in Delhi. There are many challenging tasks, but the overall idea is that you have the lot of information available from the satellites. We do also have the operational techniques, but how really we automate these techniques so that you run a particular algorithm or run a particular model and you get the output at the fastest time, so that the information reach the needy at the earliest. So I urge all the participants to make best use of these data sets which are available. You will come to know how these data sets will be provided to you from the ISRO geo portals, and couple them with your innovative skills and bring out the solutions, of course keeping the sustainable development goals in the view. So I will not take much time because you have many interesting talks to be covered, and particularly Professor Pennan will be talking about the QGIS and the Mapathon and also about the FOSSEE, which you will be really utilizing those tools for developing the solutions. So I sincerely thank all the participants and wish that they really come out with good skills, and it is quite possible that once these skills are demonstrated, it is quite possible that many of those skills we would like to utilize and automate on our geo portals in ISRO. So thank you very much.
Thank you, sir, for the wonderful speech. So going by schedule, we will start with the first session, which is introduction to this Mapathon. And what are the questions we have to answer, how to answer this, and what are the tools we give through this Mapathon for you to use and resources. So with that, I'll share my presentation, and participants, put your questions on the YouTube channel. We will answer it, and sometimes the experts can also answer it through the Google Meet. So save your questions for the Q&A session, but also we will take questions now and then in the YouTube. Thank you. So with that, please share my screen. Is my screen visible?
Yes, sir.
For some reason, it is not allowing me to. Okay, 1 second. Okay. Is my screen, my presentation visible?
Yes.
Your presentation is not visible, but the Google Meet screen is visible.
Visible now, is it? Or let me pull out the second monitor. Visible now?
Hmm.
Some Is my presentation visible?
Yes, yes. Now it is visible.
Yes.
Okay, thank you. So, warm welcome to all the participants. Good afternoon. It's good to see that a lot of participants are already joining YouTube. So, what we'll discuss now is how and what is this Mapathon about. On the content side, what is a Mapathon in general? And this is a very unique and specific Mapathon. We'll go into the details of how it is specific. Why and what is the need for right now a Mapathon in India? Because there's a lot of hackathons. So what is this need, especially with mapping and QGIS? The specifics about IITB, ISRO, AICTE Mapathon. There are a lot of questions on the website. So we will go through a little bit of that. Steps involved in the Mapathon, what we are expected to do, and one point which was very good for us is that it is open to all Indians. So we see a lot of participation from school level to college level, and also at government agencies level. So there is no age or gap between what education you have to have for this Mapathon, which is very good. So the benefits for mappers. So we know that the maps are made for India, but what specific benefits does the mapper get, like other than building the QGIS and other tools and knowing about ISRO data? Specifics about GIS would be given an introduction, and the FOSSEE spoken tutorial resources that you have for QGIS. Again, please note that there are multiple open source softwares, but we specify QGIS. You can use still any open source software, but we specify in QGIS because that is what we have prepared for FOSSEE and spoken tutorials. And ways forward, what is coming up after the Mapathon? We'll start with that. Okay. So what is this Mapathon? In general, a Mapathon is just making maps, bringing a lot of people together, and they will actually work on a similar theme or a theme that is new and novel they will look at. But how is this Mapathon different is that they make maps and they also build a capacity of people to make maps. There are two aspects in Mapathon. One is you make maps, you understand the data, and the second part is that you actually build a capacity and an army of people that can make maps. Why do you need maps? Because maps have been used across every discipline now. If you look at ranging from humanities and science to even geography, geology, everything now use maps. And there are a lot of softwares to use maps, and that is where the Mapathon here we specify that you will be using an open source. I'll come to a part why we specify open source so that it is more clear. And in a Mapathon, there is two parts. As I said, you make maps, and that is a software that you use, and the data. You understand the data. So there's lots of data that's being generated, which can be mapped. We will go through the steps in what differentiates a data from a mapping data. And a lot of time it is expensive. Okay, so making a map and getting these data is expensive. That is why this Mapathon, specifically we say open source, so that you can use what is freely available for everyone. This is what has made a very unique combination. IITB is one of the leading education centers in India, and ISRO is a leading space agency across the globe, and the only one for, the most important one for India. And AICTE, as everyone knows, is very important for education system. So here we are bringing together all these partners. IITB also is the technical partner because they would like to see what can be done with these databases that we create. So it brings together a beautiful combination of these three key players. So here we use QGIS as a software, an open source software, plus the ISRO data set. There is lots and lots of data available online, different satellites and sources, but our own ISRO data set we need to use. Okay, so there is a reason, because we need to promote our own data set, which has tremendous potential and capacity, and that is where this Mapathon is very unique. And we are making maps for India. Okay, so that India maps can be used by others in any field relevant to their specific research interest or question, and they can use it. For example, if you make a road map, you may not use a road map for a place in Mumbai, but someone who has access to the map and they need to use it, they can use it. And that is what we are trying to promote here in open archiving the maps. So let's look at the need for Mapathon, especially in India. Need for local maps. Maps, local maps, when I say local maps, it is made at a specific small scale, okay, or higher resolution at a very small area that covers a very small area. Those maps are still missing. And because these maps take so much money to make and an investment of time and human capacity, it is very, very difficult. So we still need a lot of local maps that can help. And it could be related to anything like bird migratory, pollution, water, drought, as the speakers were saying before. Okay, need to access the data. A lot of times you don't get access to the data. It could be observed data, you don't get access to it. There's a lot of blockades. So what we do is we bring them together in a mapping environment, because ISRO data, it is a data that is taken for a different purpose. Okay, it's an image or something, and we try to include it into our problem statement. So that is where the need for access is taken care of this. Need for a data update. So most of the data you see on paper format that I'm showing here on my screen on the top right is a paper map. Most of these are still dated to the British era. Okay, so we don't have an updated map. So this is the time when a local map can be updated by local people, because you know the area better. If you select the state that you are from, you would have more information than us. So that is where we are bringing all this information together. Need for local capacity. It's not only that we want to get the data and map it, but also you should map it so that you will get the capacity. You know, like suddenly if your district collector wants maps, they should not be going out to a consultancy which charges a lot, but can get students and anyone who has participated in this Mapathon to make the maps. A lot of consultants charge very, very high amount for these kind of maps. So here we are building a local capacity so that you can make these maps. So on the bottom, what you see is a lot of self-done maps and maps that can range from India scale to a very road scale, very, very small scale, and also some research analysis. The contour maps you see on the third is contour maps. And what does this lead to is a self-reliance, our own motto we have, Atmanirbhar Bharat. Right? So we can build this together, like making maps and a lot of data. The partners, very interesting partners, as I said, we are all leaders in our own field, IIT, ISRO, and AICTE. And with this, I would like to get into the website for a second to see, to explain what is in the website, resources, so that those who are interested can actually get the data from it. Because there's a lot of questions we're getting, but all these information are shared in your website. Okay, so let me open the website for a second. So when you open the, is my website coming on the screen?
No, sir, it's a presentation which is still on the screen.
Stop sharing. Okay. Yeah, my presentation should be there, right? Is my presentation there?
No, sir. Now nothing is shared.
Oops. Okay. Share. Yeah. So the partners you see on the top are all the major partners that are contributing to this webinar, and the home tab, about, problem statement are all in the home page so that you can easily access. We have a special FAQ section where you can see what questions have been already answered. Let me start with that. And you could see that you can post your question to the forum. You can actually go to a forum and ask people the questions. And some of our students are ready to help you. Okay, you will have to first register to get into the forum and post your question, and the students will be happy to help you. And these are some of the FAQs. We always populate it. So when we started the Mapathon event, it was 5 questions. Now it's 9. So slowly, if your questions are coming relevant, we will add it to here, okay, so that everyone can access to it. So coming back to the home. Okay, so in the home page, you'd see the important dates. Please go through the dates. It is very, because we close it at the midnight. So if I say 18th, we close registration, by midnight it will close. And once your registration is over, you will be getting a submission link with a submission number. So please wait for that, and I'll give you a slide on when you should contact us if you don't get the information. The results will be on January. So if you click the registration statistics, you can see an updated map of where the registrations have become. Total registrations right now stand at 8 a.m. in the morning at 3,068, which means 3,068 teams were registered in the morning, and total participants are 4,881. If you look at the spread, it's a beautiful spread that we cover all the regions, including Andaman. Lakshadweep we're still waiting for. But the other thing we look at is, if you look at the participants themselves, you see that some range from even homeschool, which means a student which doesn't have access to school or homeschooled, even they are participating. And right from there to the top universities and colleges in the country are participating. All the IITs have registered, and NITs and even government agencies. We also have medical school and law school. So that's how this data can be useful for any discipline. So you can look at some details about the Mapathon, a very short and very brief introduction. What is a Mapathon that we covered? It is about making maps, but not just any maps. Whatever you're going to make would be accessible to the general public. So it is kind of helping to create databases. The eligibility to participate is all Indian nationals. There are a lot of questions on this. You have to be an Indian national to participate. And then the flowchart is very simple. You register, you learn or use any open source software, example QGIS. We have given enough time for registration and making the maps so that you could even learn this software. It is quite easy and self-learnable. I learned it myself. So if I could do it, I think most of you can do it with the resources available right now. You could look at create maps with boundaries. So also the boundaries and data we are giving, and then you submit it, win certificates and prizes. The benefits is we will be building a capacity of space applications and also recognition for the ISRO data, making us an Atmanirbhar in global GIS hub. You will also be able to think about these problems because you are making these maps. Okay, so all these 10 statements will be covered by ISRO in a very detailed manner after me. You will also have the resources. Most of the resources will be discussed today by our own ISRO partners, and which links you can get. Okay, this is a very important link. So for example, all these databases would come in different spatial resolution. But if you want your own district or own state, you can come here and click this link. If you click this link, it will open a FTP site or a storage site where you could download the shapefile. To know what these extensions are, you would need to take the tutorial. So those who know GIS know which of these files represent the GIS format. So you can just click it, and you can see here that I have boundaries at the India scale, that is the entire India boundary, the district boundary and state boundaries. So we have 3 levels of boundaries available for you. Please use this data because the other data are sometimes you get from online may be different. And we're putting a disclaimer, this is only for research purposes. Okay, so please don't use this as the definite boundaries. It is for research and problem solving. The tutorials, as I said, you could go to this link and you would be taken to QGIS tutorials that we have made, and it is always available for public, and it is also available in different languages. We are also updating it in English, Hindi, Malayalam, Tamil, and other languages are coming. I'll get into what is QGIS from FOSSEE and SD later in the thing. Then we have our partners, and those, if you would like to share this poster, click on the poster and a good poster comes up. You can easily share this with other students and participants. Okay. So this is all with the web page, and if any questions, please get back to us on this mapathon@fossee.in. You can also go to the forums and place your questions. Okay. So let me now share my presentation again. Okay. Is my presentation visible?
Yes, sir.
Thank you. So participations, we are very happy. To be honest, we didn't expect so many regions to be covered as soon, like within a week. All major regions are now covered. Most of the districts are being picked across all schools. When I say across all schools, I've noted in the registration we have ranging from Private schools, public schools, government schools, all the schools are present. So we have all that is the beauty of this open source. It is free for all, and the software is free for all, so everyone can use it. It is across ages. I've seen school students, college students, and even working professionals from government agencies participating. Sectors, as I said, there's law school, medical, and different disciplines are also participating. Across agencies, we have been very fortunate to get many government and private agencies, even consulting agencies have participated. A homeschool, that was very, very happy for me to see that a homeschooled student is participating, and it creates a leveling playing field. So everyone is put on the same scale because you're using an open source data and also an open source mapping platform. So the participation is very good. So it is going to be a tough competition. So this is what I updated a couple of days ago, and you could see the beautiful presentation. Yeah. So what are the benefits? It makes on overall scale, I'm saying it makes India an Atmanirbhar Bharat and creates a self-sustainability. Space applications has been targeted here because one side you collect this data, but you also need to apply this data, and that is when you associate with a problem statement and you start applying it in a very detailed fashion. It also makes pathways to make India the global GIS hub and an enabler platform for collaborative problem solving. Once you understand this problem, you will get noticed that it is not a one discipline or one man's solution. You will have to bring in a lot of team and a collaborative problem solving environment. That is what this will help you. All of you will be recognized for your work. All submissions will get a certification and prizes for the top best submissions. Recognition of capacity, I will stress on this because once you've made these maps and submitted, it will be housed in open archive systems in a very detailed fashion. For example, we'll have India's map and all the, let's say Maharashtra, all the maps in Maharashtra will be put and segregated by discipline. So anyone who wants these Maharashtra maps can just click Maharashtra and then click, for example, I need schools, COVID hospitals, they can click these maps and then look at it. So, and we will not take the credibility, we will and also the credits for the work, it will be given to the person who made the maps. I'll show you an example. So how do you make maps? Now I've shown you the data, and ISRO would be following up with what data they have and available for free public. But before that, let's take a step that now you get the data, how do you map it? And that is where GIS comes. So GIS is a computer-based system, a simulation or software tool, which is helpful for collecting and arranging and managing your spatial data. Spatial data is data which has an association with a space. For example, if I take a number or any record, if it doesn't have a space attached to it. So now I'm attaching Chennai, for example. I know a number of population, which is 20,000. Now I'm attaching Chennai to it. So now I know Chennai has 20,000 population, whatever population it is. So that is the association that GIS builds. So that is spatial into GIS data. It also allows you to take one data set and apply different models to it. For example, you cannot just take census data and understand why or how many people have to get medicine. Right? So you have other data, and that GIS environment gives you a lot of freeway. You can bring different data and make it into one data source. So data was information. Data by itself differs from information. Data is of little or no use, I would say, without transformation into information. That is why we say information technology, not data technology. Data is just numbers and things you collect. Information is when you convert it into something useful. Information is an answer to a question based on raw data, and that is done by your GIS systems. We transform that using GIS. Example, population data, if you just give numbers, there's no meaning, but if you attach it to spatial indicators or spatial data, then it has a meaning. So GIS not only helps you to make one data, it takes all the data together and gives you a composite understanding of the problem, because the problems are complex. You cannot just have one data to explain it. You need a complex data structure. The GIS process starts like this. It's very simple to our Mapathon. You start with a defined problem. Okay, you define a problem or take a problem. Then you understand the problem and understand the GIS criteria, what maps to make, how to make. that is your flowchart. Then you go to build dataset, import dataset. Here is where ISRO has the dataset ready for you, and you can also bring your data. For example, ISRO can give you the land use, land cover data, and you can put specifically where the Anganwadis are present, where the schools are present. That is your data. You can build it into it, and that is where GIS helps. Then you can do some analysis, GIS analysis. For example, I can say how far is the distance between the school and the hospital, and that distance can be calculated in GIS. Then the output, you can take the output as a map, and that map, it will lead you to make a decision on the problem. You had a problem, you come through it, and let's say, as I said, I need to know what is the distance between the school and the Angan and the hospital, because if suddenly happens, I need to get the children to the hospital, and these are the criteria I build, I get the data, and I come to a decision. Like, what is the distance? But I don't stop there. I can even continue to refine the problem and go through the cycle again. So this is what GIS helps you. Okay, so now we've looked at a software, what you could use, and what are the data that comes in. Okay, so a lot of data is stations, survey, field, register data. They look like this. You collect data from the field, your PCA analysis from the villages, your census data are numbers and tables. Okay, you can collect data from IMD's weather stations. Everything is online. You can also look at newspapers and collect how much locust. So what you're seeing is a locust insect taking up a field, and also big data. So data comes in different formats and the sizes. You can take any data you want. These are observed physical primary data. You can bring that into a remote sensing environment. You can combine that with remote sensing environment using GIS. So now we've looked at why you need GIS as a software tool and the data that can support to it. You can start with observed data and also join your remote sensing data. And these are some of the satellites, very beautiful satellites from ISRO that you could use. Okay, so why open source? Again, proprietary software is very, very expensive. So we promote softwares that is free and open to everyone. And India is slowly moving into that sector. So I started learning proprietary software in my PhD because there was not much open software. But now that is being built so that everyone can use it. It's very expensive, these software. So we are promoting the use of open software. And one of them is QGIS. You can go to this site and you can find how to download and what are the different options to download. Always download the stable version. Don't go for the newer version. The newer version is always they test it. They keep testing and updating it. Always go for the stable version because for your application, stable is very, very important. So overview of GIS, QGIS specifically, Quantum, it's called Quantum GIS, was started early 2002 by Gary Sherman, and it is under public license so anyone can use it. It is very versatile, unlike proprietary software, it can run on any operating system. And it has a very live and vibrant GIS community, QGIS community. What do you mean a community? Is they co-develop this platform, and if any question comes, they can answer it for you. They can make modules for you, like we are making tutorials that we are part of this community. And by participating in this Mapathon, you become a global community of QGIS because now you know how to use QGIS. You can also go to this forum and answer questions. The forum is also given in this link. Let's go to the top link. You will see the forum. Time is available. I will come back in the Q&A session for that. Then not only we, India, but many countries are using QGIS. It is used in the US National Security Agency. It is used by Swiss agencies and New Zealand government agencies for their mapping work and other work. It looks like this. If you start QGIS, you get an open blank page. I like to have it always with India map. So I have an India map. What you see on the left is all the data that you collect and put for the mapping. On the top, you have tools that you can use, and there are many tools that you can bring in QGIS. And on the right panel, there are different options that you can choose for processing your data, like calculations and stuff. All of this has been very detailedly explained in tutorials, and you can also use our own spoken tutorials for it. The newest version is 3.16. I'm always using 2.18 because I have very good knowledge about the tools, but you can use the newest version, 3.16. Hanover is being released now. It also gives you plugins. So if you have good computing knowledge and you would like to build the tools, like a startup of tools, you can build the tools and give it to QGIS. They will host it for you. So each tool, if you click, it's called plugins. It will give you like what it exactly does. So it generates a matrix. So you can enable this tool and then bring it in. So unlike proprietary softwares, only some tools you can use which are built by the company. But here, even a community built tool you can access. Any tool you can access that is built by the community and given in QGIS. And this is how it looks like. You go to the plugins and you can see all these maps. You can also bring Google, Open Layers, Bing Roads, everything you can bring in QGIS. It is very powerful. Not only that, you can also do some good analysis, research analysis models. So SWOT is a hydrological model developed by US Geological Survey and also housed by Texas A&M, which is a good university in the US. And now they've combined it in QGIS platform. Initially, it was for the proprietary software. Now you can use this software. So everyone is going into this. So now I've given an introduction. How do you learn? And that is where our own team of FOSSEE and Spoken Tutorials helps. Go to qgis.fossee.in. You'll see this beautiful page of resources, how to get to tutorials and forum, especially questions, how we answer questions. We also give fellowships for very talented students to conduct QGIS research on campus in IIT Bombay. So we are hoping that will happen again after COVID situation. And all these details you can get in the FOSSEE QGIS website. What is FOSSEE? FOSSEE is the project that Professor Kannan Madgalia leads, and it is for free open source software for education. And the website is fossee.in. If you go there, it shows you that it promotes the use of open software for education. There's lots and lots of open software, and we focus on some software with the resources, which means we give spoken tutorials and also manuals on how to use it. Right now, the projects range from 9 to 10, and QGIS is part of it. From the FOSSEE, you can go to Spoken Tutorial website, and what does the Spoken Tutorial have is a tutorial of all these softwares that I've mentioned. There's many software projects. If you click all courses, all the courses will come and in different languages. We don't want to limit it to a particular language or a region. So there are many languages in India, and we're trying our best to make these spoken tutorials very informative video tutorials and in different languages, because we should not have a language barrier. I'll show you quickly how it looks like the website. You can go to QGIS in the search projects, and QGIS is one project. And you can see that already we have different languages. English, we have the most, 16, and that is being slowly translated into different regional languages. Hindi, Kannada, Malayalam, Tamil, and other things are coming. So here you can see how do you install. How do you install in Hindi, English, Kannada, and also the right hand side you see if it is a basic, advanced level thing. So right now we are starting with the basics, and intermediary we have come. Slowly we'll get into the advanced tutorials for all the students. So anyone can use this. Please feel free to use it. What can we achieve? So now we've seen that you can use all these softwares and get the data from ISRO. What can we achieve? We can achieve data that can help in different disciplines. One example is agriculture. And you could see how it can lead to a big data framework. Big data is with large volumes of data, right? And for all of your information, big data means large volumes of data in large frequency. And your satellite data is default big data because it comes in very big volumes and in high spatial and temporal resolution. So it is very big data. You take it, you process it using QGIS, and you can use it in these kind of frameworks. You can also use it for real-time applications. This is the recent Burevi cyclone that hit South India very bad, and you could have seen it being tracked beautifully in ISRO's team, and how and what time it would impact. Everything can be mapped. So all this data is in remote sensing data. You can bring it into a QGIS layer and then do these kind of maps. So this is one other application. You can see how the locust started in Africa and then moved to India, right? So all this could be mapped, and it is better to see it visually so that you can comprehend what is happening. Right now, this map is very famous. Everyone sees it. This is an open source website. You can go there, get the data, and put it in the GIS environment, and you could see how the hotspots are emerging. So the dark blue hotspots are where the cases are more. You could see Maharashtra right there, and you know how the other places are coming. So all this is done by mapping, and mapping is by QGIS software also. What does this do is in recent years, normally what happens is your agency is there and policymakers, government agency is there, and scientists like us, like we work in academics and different agencies. We take a problem and we try to solve it and give it to the community. Okay, so the community is on your right. We take the problem, we discuss it, and then we give it. But what we're trying to do with this kind of a setting is we bring the community science, which means you give the data, you also take part in the problem solving so that it is a two-way process and you make these maps. So for example, if a district collector has a problem to understand a land use change land cover, he need not come to us, academics or agencies. He can directly go to the people and ask them to make these maps. Because the data is free, no one's going to stop you from using the data or the software, and that is what we are promoting. The ways forward, we would like to archive all these maps. What do you mean by archiving? Is by creating a database, a free open database for all of you to use these maps. Because it is hard work you're putting and we want you to get recognized. I'll come in the later part of today's webinar on the submission part, and I'll show you clearly how you get promoted for your work. Okay, it will be hosted with unique names and users. So your name would be put on the map and what it can be used for. So those who want to use the map can easily contact you and say if they want to update the map, then you will be the better person. Increasing potential for local collaborations. All the problems need local people also to solve. So your understanding of the maps can help. Improvement of maps with local admin. As I said, your police station might need a map. You're during a flood, as some people are saying, you need evacuation plans. You don't have to wait for IIT or others to make these maps, but you can actually make and help your local administration. The building capacity of mappers is the key, and with applications using ISRO data and QGIS is the goal. With this, the biggest thing we would like to set up after this is a hackathon. How do you build tools using these maps and ISRO data to make real life problem solving tools? Right now you're making maps. The next part is hackathon. It is much bigger, much more complex, but it's very exciting that you will be working with big computers. So what you see right here is the supercomputer in IIT, and that's what at level you'll be working with when you happen with hackathon. With this, I would like to stop. I think right on time, and I still have 2 minutes. So let me open the FOSSEE website. Okay, so yes, so yeah. Here's how the QGIS FOSSEE website looks like. You can come down and read about quantum GIS. If you click here, you can look at other FOSSEE projects, all the projects that I've explained and built in here. So then you have your resources, where to download, how to download QGIS, user manuals, documents. All the other projects in FOSSEE is also here. And we have already we have been lucky to have some good students that have participated, and these maps were made by the students and are published in international journals. So these Kerala flood maps were published by a student last time. Okay? So you have all these resources that you could use. I'll come back to spoken tutorials where you could click QGIS. You can just click here. You can have a lot of projects that FOSSEE works directly. Okay, and let's say, for example, if I click R, then I have English 23 lectures. If I click QGIS, let me click QGIS, I have 16 lectures. Let's click English and search. It updates itself. Okay, you don't need always a high bandwidth. You can also download them, but let's look at one video. I'm just clicking this video. And it opens like this. Okay, so if I click it, you'll hear a live audio. And you will also have a statement of what it is. So this is how we are promoting for you to use a new software, open source software, and giving you the resources on how to use it. There's multiple tutorials we are working on. So please keep visiting this website and looking at different tools that we create. And sometimes QGIS can be helpfully used with R and other things. So it's not only one software, there's multiple softwares we can use. With this, I'll just stop for question and answers. Any questions from the team? I'll look at the YouTube if there's any questions. Is there any questions? That needs clarification, answers?
No, sir.
Okay. So we are on time. With this, I would like to stop my presentation part, and I'll open it to the next presenter. Let me give you a small intro. And okay. So next part would be done by Mr. Shashikant Sharma, who's the Group Director, Vedas Research Group. And he'll be talking about the problem statements and the expectation from the participants. Thank you.
On the behalf of Shashikant Sharma, myself RJ Banderi is presenting from SAC ISRO.
Okay, yeah, please go ahead.
Yeah. So I am sharing my screen. Is it visible? My screen is visible?
Yes, sir.
Yes, sir.
Okay. Okay, fine. So basically there are 10 Mapathon problem statements.
Sir, your
So
audio is
we'll-
little bit low. Can you just speak up
Okay,
little
okay,
bit
yeah,
more
sure.
highly?
Hello. Now it is audible.
Yeah, it is audible. now,
Okay,
sir.
little bit clear, na? Okay. So there are 10 problems. So I will go one by one, and what exactly we have to do for that problem, and what will be the requirement, and what will be expecting from the students or participants. Okay, let us take first one: mapping of natural resources or a man-made features. So basically, we have to map the natural resources like agriculture area or forest area, water bodies, or man-made features like built-up area. So any man-made constructions. So that kind of resources can be mapped. So to map these features, what will be the requirement? We need remote sensing data like list 4 data or list 3 data. So this type of data will be required. And one has to learn how to interpret the imagery. So we have to interpret the imagery, and we have to extract the information from the imagery. So we have to work out, okay, what type of tone or texture or a color will be the reflecting, means resembling the particular features. So identification of the features on the imagery. So it requires the skill to interpret the imagery. As well as some ground knowledge also is required. And after knowing all these things, we have to do the automatic extraction of the features. So for that, computer based image processing also is required. And all this type of input data will be available on the BO1. So one can take this type of problem and work out flowchart for it, and one by one step can be executed, and finally come out as a map, thematic map. Thematic means it is a represents particular subject. So come out with some particular subject map or a thematic map. So that will be the output. And if you see second problem, so that is change detection based on AWIPS or list 3 data sets. So what type of change detection? Any suppose say forest area, what was the before, then this date. So two type of database we have to take and interpret both the data sets, whether visually or digitally, and then overlay to both the data set and come out with the change. So one has to work out all the steps and flowcharts and execute it one by one and come out with the change map as well as change statistics. Okay. Then third one is LULC, land use land cover change with hotspots using land use land cover maps available from the Bhuvan. So we have on the Bhuvan to 50,000 scale as well as 50,000 scale data sets. One can directly download this ready-made data set, use it, and come out with change, particular change wherever hotspots means dynamic changing area means some significant change should be observed. So that change map one has to prepare as a output and come out with the statistic how much change is there. Then fourth problem, flood mapping. So we observed that in India at many places flooding is happening in every monsoon season, like in Bihar, Kosi River, Brahmaputra. So at many places we observe the flood. So we have to map the flood. For that we have to consider pre and post season data sets. So post pre monsoon, just you observe that what will be the normal condition, and then post monsoon how much area is inundated. So that area will maps we have to prepare, means one has to prepare and come out with the statistic how much area is gone under the inundation. Then state-wise healthcare indicators maps. So this type of database one has to take from the health department or that sites, and then healthcare map indicators one can find out and prepare the healthcare maps. So there is not much remote sensing data sets roles. Then sixth one is locust infestations, stubble burning, low-lying area mapping, zoom cultivation. So we observe that at many places there is a locust attacks, and in particularly in Punjab you can find out stubble burning, means residue, crop residue, they burn it for next cropping to clear this residue for next cropping season. So to find out this type of area, one has to take that seasonal images and interpret those area particularly, and find out how much area is under stubble burning. Then low-lying area, particularly where in monsoon season it goes under flooding, means water gets accumulated in the low-lying area. So for this type of study you can use DEM and find out slope, so that you can find out low-lying area. And in case of zoom cultivation, particularly this type of phenomena observed in the northeast area, in hilly area particularly. So in the northeast area, what happens every year or for a particular season, people used to burn the forest area and clear some patches for that agriculture purpose, agriculture practices. So this type of practices is happening in northeast area. So for that you have to study the